So, up to this section, we learn about the concept of the reflection and transmission of the wave. Now, let us learn the application of this concept. As we discussed, we are going to learn this concept application through few selected illustration. So, let us move to illustration number 1. In illustration number 1, a progressive wave get reflected at the boundary such that the ratio of the amplitude of the reflected and incident wave is 1:2. We need to find the percentage of the energy transmitted. Okay. So, let us analyze what is given. We are giving the ratio of the reflected and incident wave. That means AR divided by AI equal to 1:2. This is given. Okay. And we need to calculate the percentage of energy transmitted. And we learn in this theoretical part, the percentage of energy transmitted is equal to 1 minus, or fraction of energy transmitted equal to 1 minus AR divided by AI square. And we have calculated these energy in term of intensity, that is the energy per unit time per unit area. So, here we can write energy transmitted, the fraction of energy transmitted as 1 minus AR divided by AI whole square, that is 1 minus 1/2 whole square, this much. Okay. This is equal to 3/4, and 3/4 if we convert in the percentage, this is equal to 75%. So, we can say 75% energy, that is the energy per unit area per unit time. In fact, this energy is expressed in term of the intensity. So, we can say 75% energy is being transmitted. Now, let us move to the next problem. In this illustration, question is a progressive wave travel its speed in medium 1, and that is the M1, enter into the medium M2, in which speed decreased to the 75%. That means, when wave enter from medium M1 to medium M2, the speed decreased by 75%. The question is, what is the ratio of the amplitude of the reflected and incident wave, and second part of the question, transmitted and the incident wave. In fact, this problem is directly based on the formula which we have calculated. We have calculated these two formula, that is the amplitude of the reflected wave in term of the incident amplitude, and amplitude of the transmitted wave in term of incident amplitude. Okay. So, let us consider AI, AR, AT are the amplitude of the incident, reflected and transmitted wave. Okay. And according to the question, velocity of the wave in the medium 2 is 75% of the first medium. That means, V2 equal to 75% of V1, and 75% in term of the fraction, you can write 3/4 V1. So, we can write V2 equal to 3/4 multiplication V1, right. Now, remember the formula, that is the amplitude of the reflected wave, that is AR equal to V2 minus V1 divided by V2 plus V1 multiplied by AI. This is the expression we have derived, right. Now, we can write this expression in term of this V2 by V1. We can write V2 minus V1 equal to 3/4. So, let us take V1 as common. So, this equation will become AR equal to V2 divided by V1 minus 1, and here V2 divided by V1 plus 1, right, this one. So, if we substitute the value, this is equal to 3/4. So, this is 3/4 minus 1 and 3/4 plus 1. So, after calculation, this value is minus 1/7, right. So, we are calculating here the magnitude of this amplitude, the ratio of the amplitude. So, let us take the mod of this. So, if we take the mod of this, this is equal to 1/7. So, required ratio is 1/7. Now, let us move to the next part. Next part of the question, it is about the ratio of the transmitted wave and incident wave, that is AT divided by AR, and we have again formula, right. We have this formula, that is the amplitude of the transmitted wave as AT equal to 2 V2 divided by V2 plus V1 AI. right? Again, we can write this formula in term of the ratio. So we can write, we can take V1 as common. So if we take V1 as common, this ratio will be equal to 2 multiplied by V2 divided by V1, and here is V2 divided by V1 plus 1, right? And we can rearrange this equation. If we can substitute now, and after solving, this is equal to 6 by 7. And now we can write this ratio 80 divided by AI equal to 6 by 7. So this is the required ratio. Okay. Now let us take another illustration. In this illustration, a harmonic wave is traveling in string 1. At a junction with string 2, it is partially reflected and partially transmitted. The linear mass density of the second string is 4 times the first string, and the boundary between the two strings is x equal to 0. If the expression for the incident wave is y I equal to a I cos k1 x minus omega t, and we need to find the expression for the transmitted and reflected wave in term of a I, k1 and omega 1. Okay. That means we need to write the equation of the transmitted wave and reflected wave. Okay. Now let us analyze for calculating the equation of the transmitted wave and reflected wave, what additional term we need. We are given the amplitude of the incident wave, and we have the expression for calculating the amplitude of the transmitted wave and reflected wave. That means for writing the equation of the transmitted wave, we need to calculate this value, that is the amplitude of the transmitted wave, and calculating the equation of the reflected wave, we need to calculate the amplitude of the reflected wave, right? And here value of k1 is the wave number for the first medium. This wave number is the property of the medium, and this depends on the wave velocity. That is, the wave velocity and k1 both relate with the medium property, and we know the expression for k is equal to omega divided by v. Omega is the angular frequency that remain unchanged from medium to medium. That means the value of k depends on the medium. That means in the medium too, the value of k will differ. That's why for writing the equation of the transmitted wave, we need to calculate the amplitude, also the value of k. Okay. So we have analyzed the situation. Let us move to calculate first the amplitude of the transmitted and reflected wave, right? And we have the formula for the velocity of the wave in the string. This is v equal to under root t divided by mu, right? And in our question, it is given the wave is traveling in two strings. These are connected one by one. This is string 1 and junction, that is the boundary, and then string 2. So we can write velocity of the wave in the string equal to v divided by under root t divided by mu, and this is the scenario, right? Because we are also given linear mass density. Okay. The value of mu in the second medium, that is linear mass density, the second string is the 4 times the first string. So first string is thinner one and second string is thicker, right? And we know both strings are connected side by side. That means tension value in the first string and second string will be equal. That's why we can write T1 equal to T2, right? And we are given mu2 equal to 4 times mu1. This is the linear mass density. Now we know the value of the tension is same. That why we can write V is inversely proportional to under root of mu. That is the linear mass density. Now we can write V1 by V2 equal to mu2 divided by mu1 and under root overall. Now we can write mu2 equal to 4 mu1. So this is under root 4 mu1 divided by mu1, and this is equal to under root 4, and that is equal to 2. Okay. Now we can write V1 by V2 equal to 2, or you can say V2 equal to V1 divided by 2. Let us call this equation as equation number 1, right? As we discussed, the frequency remain unchanged. That means omega 1, thus the angular frequency in this string will be the same as angular frequency in second string. So omega 1 equal to omega 2, right? And we know wave number k equal to omega divided by v, that is k is inversely proportional to v. That's why we can write k1 by k2 equal to v2 divided by v1, and v2 divided by v1 is equal to 1 by 2. Okay. So, we can write k2 equal to 2k1. Okay, this is the second equation. So, let us do one thing. Let us write the wave velocity relation, this relation, and this wave number relation to the next page. This is the scenario of a string 1 and 2, and these values we have calculated. Okay. Now, we have the expression for the amplitude of the transmitted and reflected wave. We can express the amplitude of the transmitted wave as 2v2 divided by v2 plus v1 multiplied by ai, and we have the ratio v2 divided by v1 equal to 1 by 2, and here if we take v1 as common, so this relation will be equal to 2 multiplied by v2 by v1, and this is v2 divided by v1 plus 1. Right. Now, this value v2 divided by v1 is equal to 1 by 2. We can substitute, and after solving, this is equal to 2 by 3 ai. This is the amplitude of the transmitted wave. You can observe here this value is lesser than the amplitude of the incident wave, and it is having the positive value. That means the sense of oscillation of the medium particle will not change. That means there will be no change in the phase. Okay. Now, we can calculate the amplitude of the reflected wave. We have the expression this AR equal to V2 minus V1 divided by V2 plus V1 multiplication AI, and here also we can take V1 as a common. So, this is V2 divided by V1 minus 1, and here is V2 divided by V1 plus 1, and V1 will get cancelled, then final equation will be this much. Now, we can substitute V2 divided by V1 as 1 by 2. So, it is 1 by 2 minus 1 and 1 by 2 plus 1, and you can observe here this will be a negative value. Negative value means phase change of pi, that is sense of oscillation of the medium particle will invert it. So, this is equal to minus ai divided by 3. Let us call this equation as equation number 4. Okay. So, let us write these equations to the next page. This is the first, second, third and fourth. Okay. Now, we have the equation of the incident wave. Equation of the incident wave is this much: yi equal to ai cos k1x minus omega 1 t. So, let us write this equation of the incident wave. Okay. Now, we can write the equation of the transmitted wave. You know, the transmitted wave is traveling the same direction as the incident wave. That means there will be no change of the sign between k1x and omega 1 t, that is k2 for the second medium. So, we can say k2x minus omega 1 t, the sign will be negative here, because the sense of motion of the wave will be from left to right, and here we write the amplitude of the transmitted wave, that is 2 by 3. So, we can write yt equal to 2 by 3 cos 2k1, instead of k1 we write 2k1 minus omega 1 t. So, this is the equation of the transmitted wave. Now, let us write the equation of the reflected wave. For the reflected wave is traveling in the negative x direction. So, there will be positive sign instead of negative. So, let us write the equation. This is the equation, and here this is the negative sign. Okay. So, this is the phase change of the pi. So, we can write yr equal to ai divided by 2 cos k1x plus omega 1 t plus phi. This is the equation of the reflected wave.